Hello guys, welcome to lecture 7 of coordinate geometry series. So we'll continue with the problem. So finding distance between any two points, it can be stated in this form also. A line is of length 10 and one end is at the point 2, minus 3. If the abscissa of other end is 10, prove that ordinate must be 3 or minus 9. So in previous video we have solved the value for x1. So that problem can be stated like this also. We need to prove that x1 could be this or this. So let's move to the next problem. Prove that the points 2a, 4a, 2a, 6a and 2a plus root 3a, comma, a is outside of that root, right, comma 5a. Prove that these 3 points are the vertices of an equilateral triangle whose side is 2a, right. So there are many ways of solving this problem. What we need to prove that there is an equilateral triangle and the side is 2a. So one thing what we can do, we can plot this point, and after plotting that point we can check the distance between any 2 points. And the best method is what? If we pick any point, what are the total left points? This one and this one. So in any triangle with this point I can find distance with this point, I can find distance with this point, right? And then from this point we need to find the distance with this point and this point, and from this point we can find the distance to this point and this point. But as you can see, there will be repetition of finding the distance between any 2 points. That is the twice we are evaluating the distance. So what we can do, we can call it as A, we can call it as a B, we can call it as a C, right? We need to just find out AB, which is one of the side. We'll find BC and we'll find AC, right? And if all these 3 distance equal to 2a, we can prove that this is an equilateral triangle, right? So this is the sufficient condition. What is the sufficient condition for equilateral triangle? All these 3 points should have the same distance, right? So if you take any 3 points on any plane and if the distance is same between these 3 points, then those 3 points will definitely an equilateral triangle. If someone think that if I put a point here, so this distance is same, this distance is same, but the distance between these 2 points is not the same. This is sum of these 2 points, right? So what we need to do, we need to move this point to here and check distance. So let's find out the distance between AB. So what is the distance between AB? Difference of x-axis, that is 0 square, difference in this 2a whole square under root, which is nothing but 2a. AB is 2a. What is the distance between B and C? B and C. And what is the distance between these 2 points? B and C. Difference between this and this. So 2a plus root 3a minus 2a, we left with root 3 of a. Root 3 of a whole square plus 5a minus 6a, that is a ka square, right? Ka under root. What is this? Root 3a square. 3a square plus a square, which is what? Root 4a square, which is nothing but 2a. Okay, fine. BC is also 2a. What about AC? Difference between 2a and this one, right? We left with root 3a. Root 3a whole square, 5a and 4a, that is a square, under root, which is nothing but 2A also, same this one. So AC is also 2A. So as we can see, AB is equals to BC is equals to AC is equals to 2A. So this is an equilateral triangle. Proved. So guys, please subscribe and share these videos and promote free education. Thank you.